Hello, and welcome to the Industrial Innovators podcast, hosted by founder and CEO of Innovator, Don Cooper. I am Wyatt McPherson. I produce this show, and today our guests are Alan Barker, along with Gavin West from IK UK, and they and Don will be discussing the test plug options that they offer, along with exciting new technologies, as well as their long-standing business relationship. So let's hear what they have to say.
Talking with our technology partners from IK UK in the beautiful town of Newton Aycliffe in sunny England, and what we're going to be talking about, I think isolation and test plugs today, right, guys?
Yep.
Is that the plan? Cool. So, guys, why don't we start and just tell the audience that'll be listening when the podcast airs who is IK and the company history focus that sort of set the stage for who you guys are.
Okay. IK UK, where we are here in Newton Aycliffe, it was originally a company called Poly Europe International. They used to do all the same products we do, and they were eventually bought in 2013 by the IK Group, which are a Norwegian company. So that was when the name changed. And in 2015, we were joined by our sister company up in Aberdeen, Online Electronics. So we're made up predominantly, even though we've got small worldwide offices, predominantly of us in Newton Aycliffe, Aberdeen Online Electronics, and our headquarters, if you like, is in Norway. And that's where we started from. Yeah.
Mm-hmm. And what's across the business? What's the range of focus of the business?
Each department, each office has a different focus. So it's all oil and gas pipeline orientated, as we know. The Norwegian office, they seem to do a lot of large special projects. So people will go to them with last-minute major problems, whether it's subsea or topside, and they will engineer a solution and put it together and help today. They're fast-acting on major problems and major solutions. Online Electronics in Aberdeen, they do pig tracking, obviously by the name electronics. They do all our electronic-type solutions, and it is predominantly pig tracking. And they've got some quite new fancy tools being developed at the moment. And then here, our facility is predominantly pig manufacture of various types of weld testing, flange testing, high pressure plugs and tools like that. Here we do, whether it's just a quick 1 or 2 day rental of a small item up to large manufacturing of tools and plugs.
So the IK UK office, specifically in Newton Aycliffe, big focus on isolation and test plugs, big focus on the manufacturing of a variety of different types of poly and foam pigs, right? I mean,
that's correct. Yes.
That's the space. And so great. Now, today we're going to talk about a particular type of hydro testing weld test plug called the flexible flange tester. So why don't you tell us what is a test plug and what's a flexible test plug?
Well, so this one in particular, so the flange weld test, the standard one, is where somebody would, for whatever reason, they would cut off the end of a pipe, an existing flange off the end of the pipe for corrosion, and they weld on a new flange. To avoid having to fill that whole section of pipework up with water or gas or whatever test medium they wish to use, they put a flange weld tester in. So the flange weld tester is mated to the type of flange, whether it's a class 300, class 150, whatever. The test unit goes inside, and the length of the test unit is long enough to pass beyond where the new weld has been made. Then the test unit is energized to create a high integrity steel. And then all we need to do is then just pressurize that cavity or annulus, whatever you want to call it. So it's only a small volume test, and we can test that new weld to whichever test they want to do.
Right.
So that's a standard one, which has a fixed length, fixed body. It's not flexible. And the flexible one is the one we've been working on. Allows us, because sometimes these flanges are welded on near pipe bends, where so the straight tool may go in, but it may not be able to get a high integrity seal. So we're now developing a flexible one which can go around bends.
Right. Is it navigating the entire bend, or is it simply articulating part of the bend so it can capture the weld on a flange on the end of a bend? Like, what's the? I've seen both types of applications, so I'm wondering what we're talking about here.
Yeah, so ours is purely just to ensure it passes beyond where the weld is.
Right.
The problem with it being flexible, it couldn't pass too far because it'd be very difficult to put it into the pipe, because a flexible joints aren't the easiest things to push forward. Mm-hmm. So yeah, it only goes just beyond the weld enough to be able to do that small annulus test.
Right. Okay. So how was this idea conceived, and and why? Like, where did it come from?
The request came from a customer in Holland with the problem they had. Now we do have these weld testers, actually, which I didn't mention, which are elbow shaped, so they do go around bends. Yep. The problem with that is you're obviously then tied to the radius of the bend, so there's no flexibility in them at all. So we thought, well, if we have 100 customers with 100 different applications, we have to build 100 different tools. Right. So it was decided, let's build something that could be flexible, and as long as it's the right ID of the pipe, it can be used within any different bend radius.
Right. Yeah, we've worked with IK UK since the inception of the company, and our Innovator business has probably thousands of your plugs across Canada, and we've had you guys design some bespoke custom, for international customers it's bespoke, for Canadian customers it's custom design. Just to get the nomenclature right. And we've got one nuclear power plant client in Ontario that you and I worked together, and we developed some flexible isolation plugs that were also used to do sort of low to medium sized hydro tests, navigating fully around the bend and being able to accomplish some hydro tests in that way. So the range of ways that your tools can navigate bends, I think is fascinating. That the types of ways that we've been able to collaborate together to design different technology. Let's talk a little bit about what are some of the customer applications that you're seeing using flexible tools, and what are the what are the economic conditions that justify that for a customer? Why does a customer want to do that versus a full system test or in-process inspection or whatever it might be? Like, why don't we just talk about that for a little bit?
Yes. So as we said earlier, was if they don't do a local test, then they have to fill the whole void of that pipework. They may be lucky; they may have an isolation valve half a meter away from where that flange has been replaced. But typically, you wouldn't see that. Their next isolation, it could be a few hundred meters away. So that's a large volume of water. If they're using water, which is predominantly the wood, but that's a large volume of water that would have to get in there. You then have the problem of when using water and you're going large distances, you need to ensure it's filled correctly with no air. So then it involves, it's more time, it's more personnel. You then got to look at pumps, where you're going to get your water source from. So I think economically, yes, it can be done, but it's an expensive way to do it. By using one of these tools, you're talking one man, maybe two men, depending on the size of the tool, just to help load it. It's a small hand pump to put the water in. It's a small pump just to pressurize it up. There's nothing mechanically needed to drive anything. And it's because it's a small volume, it fills very quick, and it's a very short test. So basically, it's a no-brainer, I think, to use a tool like this rather than fill up a pipe.
Yeah, doing a system hydro test, there's the time, there's the volume. What I found often is not only is it a large volume, it's a lot of time, But if you've got 50 meters of pipe to test, almost in every case, there's going to be a whole bunch of branch connections. And it isn't just filling it, it's also a whole bunch of blanks and blinds that need to be installed. And it's a pretty significant endeavor to do a system test compared to a localized well test, isn't it?
Yeah, you're 100% correct there. And I think also the risk with that is you don't know how good valves isolations are further down the line. So you could be filling forever. Instead of filling that 50 meters of pipe work, you're filling 250 meters of pipe work and you're not aware of it. And then that causes further problems because you need to get that water back out.
Yeah. So it's vitally important when it's actually a maintenance activity on an existing facility versus new construction, because you don't know where that water is going, and it could be doing more harm than good.
Exactly.
So, all right. We just talked a little bit about how clients traditionally address well tests and specifically some of the challenges around elbow tests. But why don't we just dig a little bit deeper in that and kind of explore that a little further in terms of the traditional way that clients would be addressing weld integrity if they weren't using one of your test tools?
So the traditional way, again, as we've just said, would be with water. But if they decide not to do that, then the other way they do it, and we still see it done quite a lot today, is they do golden welds. But golden welds, again, it's an expense for the client, because to do a golden weld, they still need to carry out some sort of X-ray of the system. So that's expensive getting that system in. We recently did have a client where there was a miscommunication. Our tools were sent over. They were designed to their specification, but somebody on the client side had miscommunicated and put the wrong flanges on. So they did golden welds. So they had to do golden welds without even inspecting them. It was purely a visual inspection. So that side alone it's quite dangerous. So obviously clients prefer not to do that. So it's even a golden weld, or like we say, it's using the pressurized pump and water. So either of them two ways, they still have added expense compared to what we do and what we provide.
Right. Yeah, we've got clients who either don't realize that there can be a test plug used for a particular application, or some of the other competing types of plugs that are in the market just can't fit. They're not versatile enough. They don't go around bends, or they're not multi-schedule like some of your seal technologies, like the dual tool. And so then they're forced with either doing a system hydro test, planning in-process inspection, or getting a whole bunch of technical authority sign-offs on golden welds. And each of them are time-consuming. They involve technical risk, and they're all more expensive. So, but it's surprising in the marketplace how many clients don't realize the options and types of tools that are available to them to be able to isolate and hydro test in a local way, like with your technology, right? Let's talk a little bit about the value for clients in terms of safety and productivity.
Well, time-wise, it depends on the size of the job you're doing, but it can be as little as an hour. Okay, I say an hour. They've got to break their pipework anyway, so that time is a cost for them. Whether we do it, whether they decide hydro test, however they decide to do it, that breaking down has to happen. When it comes to doing the testing, for us, it's fitting on. It's no different to fitting on a single flange, a blind flange, than putting on the flange weld tester that we provide. So the time in that is just the bolting time. If it's small, it's quite quick. Then to pressurize our tools, it takes maybe 15 minutes, 30 minutes to actually pressurize and get the integrity. That's not pressurizing for the test, as in energizing the tools for the same. Maybe 15 minutes, 30 minutes. Once the seals have got their integrity, then filling in that small volume, again, 5-10 minutes, allow for a bit of stabilization time. And the tests are generally only 15 to 30-minute tests that clients want. So using one of our tools, it can be as quick as taking 1 hour just to do that test. Yeah, you might get a bit of seepage and you get a few of the issues, but these are things which are easily fixed by just putting more pressure within the seals, energizing a bit more. So the overall thing, yeah, it's a couple of hours in time cost, where any other method said there's a lot more involved in setting up and pumps and equipment. So it becomes an expensive process, I think.
Mm-hmm. What about safety? Let's talk a little bit about the advantages of doing tests this way from a safety standpoint.
Again, for safety, we're only pressurizing a very small volume of pipe work. So there's only a small area which is at risk from anybody external to what's going on. You don't have to worry about burying off 150 meters of pipe work, etc. It's very, very localized, as in even at the end, there's only that one flange. Our guys, basically, they can stand right next to the test as long as they're stood to the side and away from any lines of fire. There's no problems at all. There's no need to be shutting, never mind burying off, but on the process plants, there's no need to be shutting down large areas so other people can carry on work in the area as well. So any risk is very, very minimum. Everything which is used is rated, but again, because it's only a small product and a small test as such, there's only one hose which is under pressure, and that's when you're talking hose. It's only a small volume of water. Even if something does burst, it de-energizes very, very quickly. So there's obviously safety risks and anything to do with pressure testing, but extremely minimized with this application.
What I've always liked about your range of tools is the versatility across the different types of seal designs and tool designs to be able to be flexible in terms of low pressure tests, medium pressure tests, high pressure tests. The most of the tools in the marketplace that are available to clients are really compression O-ring tools. You're taking a plate and compressing two O-rings, and you're trying to create rubber pressure by bolting them together. With your tool designs, with the inflatable tire design, or with the partial self-energizing of the IWT, in particular, those two tools give you a lot of flexibility in terms of efficiency and in terms of being able to really get work done, I would say, much faster than the O-ring tools that are on the market. What I've seen, what most clients are seeing is a compression tool, and they're pretty good for Schedule 40, Schedule 80 kinds of piping systems, under 1,000 PSI of pressure. But the minute you get into higher pressure applications, they start to struggle, and they've got to play around with O-ring diameters and O-ring hardnesses to try to get a seal. And when we've got a whole fleet of your IWT tools, and those tools, particularly in the higher pressure and the heavier schedules, 2,000, 3,000, 4,000 PSI hydro tests, one nut, turn it, activate seals, pressurize it, it self-energizes, and you can get that tool up to pressure and performing the hydro test in 15 minutes, a half an hour, and you're in your hold time. So I found the IWT tool just such an efficient tool for doing the high pressure stuff. And I just love the tire, the inflatable tire system, because most clients who are listening to this or will be listening to this, they're not dealing with a brand new piping system. They've got ovality, they've got pitting, they've got internal erosion and corrosion, and the flexibility with the tire tool to be able to accommodate all those effectively wear and tear issues on their piping system is just far superior to an O-ring that has very minimal ability to expand and fill the gap. So I think what you guys have done in terms with tire tools and with self-energizing on the IWT are just really much better technology than I've seen anywhere else, particularly in North America. There's really no other tools in Canada, United States that are as effective at getting hydrotests done as the combination of the dual tool and the IWT. I think they are way better. I often talk with clients, and when they're used to using the O-ring type tools that are on the market, and it's the issue is they can't get a seal. It isn't that the weld is not doesn't have integrity. It's that they can't get the hydrotest to do the weld because either it's a 2,500 pound per square inch hydrotest. I'm using PSI. I know you guys would speak in bar, but most of the people in North America would be thinking about PSI, and those higher pressure tests, the traditional tools on the market seem to struggle. And so many clients have a 15, 20, 30-year-old facility, and when they're doing a maintenance weld, they're changing the piping system. They're going to have pitting and erosion and corrosion on the inside of the pipe, and I find the tire on the dual tool system is just a fantastic seal mechanism for being able to do that. And at least for us, having the combination of on a maintenance project of having both the internal weld test tools and the tire tools is a great 1-2 punch for being able to hydrotest almost anything. And being able to do that in a really short period of time versus fighting with it. Let's dig into R&D and research and development, and how has that all come about, and what's that journey look like in terms of what you guys do in R&D, how long it takes, the engineering and the factory assessment test and all that kind of stuff that you guys do. Why don't we dive into that a little bit?
Okay, so when we first did this, initial drawings, because it was an application, so the initial drawings probably take about 3 to 4 weeks trying to do some calculations and get everything correct. And when the guys model it, when they model it correctly, it will go on the bend. So this one, I say it was 3 to 4 weeks when we got to a point when we started to go to build and test in the workshop, which is the real part of research and development. We then came across quite a few issues which we just didn't expect to see, and you couldn't do on a modelling system anyway. So what we found was when we insert, well, the first thing actually was handling of the tool, because obviously as soon as you go to pick it up, it's not flexible. We're used to picking up rigid tools and they're easy to pick. All of a sudden you're picking up this thing which has got a mind of its own. So the handling and insertion initially became an issue. We'd only put on the weight support bearings, so we use them as the wheels type things. They hadn't put them on both sides of the seals. They would only put them on one side, thinking that was sufficient. Again, due to being flexible, we found just getting it in was very, very difficult. So we had to really look at that initially. Then once we managed to get it in, it wasn't seating perpendicular to the pipe wall as we'd like it to. And again, you couldn't see what was going on inside. And again, this was just due to the method of insertion and the method of supporting the seals and when it went in. So it needed a bit of a it wasn't even calculated adjustments. It was just a bit of taking it out, let's take a measurement, let's readjust, let's have a fiddle till we got what was the sweet spot. So when we finally managed to get it to go in, We then found, as we pressurized, it would start to creep and it would move out of shape. So again, even though we might have thought it was perpendicular, the way the forces were applied internal, it would knock it off to one side and it would start to extrude the seal. So then we had to start looking at how the flexible joint was fitted, the method of it fitting. And then before we even moved on to changing the flexible joint, we also found it was creeping, but we thought the creep was, as I've just said, the seal. But when we looked into it, it wasn't the seal that was creeping. It was the joint itself. And it was the material within the joint. So we basically went back to the drawing board, re-looked at calculations, and the tool we were using, I can't remember the size, I apologise for that, but we worked out that there was 30 tons of force was on the other side of the flexible joint. And we initially put a chain in, which was up to the job, but what was happening was it was actually elongating the links within the chain. Mm-hmm. So that's why the tool was creeping. As the tool was creeping, it was causing the seals to extrude.
So this was elongating the chain when you had it under pressure.
Had it under pressure, yeah.
And getting the seal portion to actually walk away from the front of the flange.
That's exactly what it was doing. It was just trying to push its way into the pipeline. Now, when the chain was put on, it's not just an open chain for protection. It's potted and sealed within polyurethane. So you can't see what's going on initially. So when we worked out and realised what was happening, it was like, okay, then we need to change this. But even though it was for the client and it was research and development, there was obviously still a time constraint. This was required for the job. So we realised the chain we had wasn't any good and we would need to get some pre-tension cables. Problem there was pre-tension cables were on a very, very long lead time, so we couldn't get them. So we had to relook at the chain. So we ended up with quite a large, chunky chain. We went to a lifting company and we put this large, chunky chain in and we re-potted it. We reset everything up. It then became extremely heavy. So at the moment, the tool is an extremely heavy and extremely chunky piece of equipment. But we managed to get it in, we managed to get it seated, and we've managed to get it sealed, and we've got it working. So at the moment, it's, even though it does work, I wouldn't say it looks pretty. It doesn't look pretty, and it is definitely a work in progress. We need to look at more lightweight but stronger materials to allow us to put it in. We need to still look at how it can be fed in and out. We've only tried it in the one bend radius pipe. Well, the whole point is so it can go around different bend radiuses. Even though it doesn't go far, it's still going to tackle different bend radiuses. So this is an ongoing development and we'll carry on testing in-house. The tool is away on the job with the client at the moment. We've had no further feedback. We've had no complaints, no nothing. So once that's finished with it, we'll come back and then we will continue with developing it further and further.
What was the test pressure for this tool that the client is using it on?
It was only 30 bar. So 30 bar give us just over 30 tons.
Okay. So, and the tire or the seal mechanism, is this a tire type seal?
It was a tire type seal. It was hydraulically activated. Yeah. So with it being hydraulically activated, it's not a solid seal, so then it's more prone to extrusion and to creeping.
Right. We use hydrostatic inflatable seals in most of the tools we've gotten from you, with I think a maximum inflation pressure in the range of 300 psi. I'm not sure what that is in bar. I can't do the math in my head, divided by 7 or whatever it is. But what's the hydraulically? What's the inflation pressure on these tools?
Well, so this one, so Gavin's just quickly worked it out. So your 300 psi is 11 bar. This one, we plan to only take it to about 15 bar. I know it got to over 30 bar in the end. But this was when it was creeping and extruding. Once we got the issue solved, they were taking it up to about 15 bar.
Okay. Yeah. That just goes to show you I'm out of practice with being in the field, and I suggested that PSI to bar was a factor of 7 when it's an atmospheric pressure of 14.7 or something, isn't it?
Yeah.
Yeah, my field days have just come back, and I now know how to do the math. Good thing for calculators, eh? So, as a company, what I've seen, we've done a lot of creative stuff together. I've come up with a lot of crazy ideas and drawn it on napkins and then handed it to your engineers, and you guys have modeled it, and then we've built prototypes, built them in your shop there. We've done factory assessment tests there. So, the way that you guys work, from what I really like and what I observe, whether it's me as a client and partner or an end user, they're coming to you with a problem. Hey, we have to isolate or hydro test this really strange situation. And what I love about IK is in your old facility in Aberdeen, which was the original online electronics office, was about 300 meters from our flat, the flat that my wife and I own in Aberdeen. So we would drive by it all the time, and of course we would see IK's little, it was online electronics, but IK had their sign on the in front of the building, and it always said IK challenge accepted. And it resonates so much with our own with our own core values around we innovate in everything we do, and we find a way, challenge accepted. And I think the values that our two companies share are really aligned. We've had a lot of great success stories because of that. For me personally, I have a harebrained idea about designing a new way to isolate or hydro test. You guys take that idea, your engineers play with it, they model it, we come up with a concept, you build it in your shop, we build the test rigs, you do the factory assessment tests, and by the time I or the client gets the tool, it's tried, tested, and true and ready to use, and it's always successful in the field because of that factory assessment testing. I think the way a lot of people see the test plug market, particularly in North America, is there's a whole pile of these standard things built, and here's what we have, try it, see if it works. And so much of what you guys do is, as your motto says, challenge accepted. And I've experienced that so many times over the years that we've built a lot of really cool solutions. And what you're doing with this flexible tool is just a testament to that kind of commitment to innovation, right?
Yeah.
Where do you see taking the technology? Where are we going with this?
Well, we'd like to obviously master at least this one size we've got, which we will do. We're nearly there. Then we need to take it, like the rest of our tools, we need to have a suite of sizes, and then see where we can adapt it into the tools we have. Mm-hmm. At the moment we have one suite of tools of one type and then another suite of another type, but there's not a lot of adaptation across them. So we need to be looking at not just applying the flexibility to the tools, but there's something else. We're actually thinking about trying to make things modular as well. So what would be ideally is where you could have an inline well tester with a fixed body, and then all of a sudden we could convert that to a flexible flange well tester by just changing a couple of components and things within it. This has purely been at the discussion stage. We've had a few talks. But we think that would be ideal, because we think giving someone an item that's modular, where they can do multiple tasks with it, is far more cost effective and beneficial than having one tool to do one particular job. So even though the flexible tester, it's a great idea, because we can use it in a flexible, so in a bend, and we can also use it as a standard straight application. It would be nice to be able to adapt it and end up with flexible inline well testers flexible twin tire multi-tools, which you have already, flexible flange weld testers, but put it along across the whole suite of tools, and that's where the objective is.
The tool that you have in that you've just done the R&D and factory assessment testing on, and it's in the field. What was the diameter size of that ballpark?
16 inches.
Okay.
Yeah, 16 inch, yes.
Okay. And, can you see this being adapted to smaller diameters, to larger diameters, so that you cover a wider suite of pipe bend diameters?
The challenge there is, depending on the size, obviously it also depends on the pressures. If somebody wants to use it in a small diameter, then we're limited to what we can use for the flexible joint and and obviously the tensile strength of that flexible joint. So again, this is something that's work in progress of what is the smallest we can do to the largest pressure we can do, and vice versa. I said, even on the 16 inch, just the handling of it alone can get a bit difficult. So we need to think that if we start getting up into 24 inch and 32 inch sizes,
you're getting into some pretty heavy rigging in terms of either the pretension cables or the chain. What I always find interesting when I talk both with technicians who use the tools and often clients is they'll say something to me like, "Oh, it's only a 500 psi test." Yeah, but it's a 36 inch diameter face, so there's a few million pounds of force there. And in designing the tools, particularly when it's flexible, you've got to take into account, because you're effectively the rigging between the seal and the opening, whether it's chain or cable or some sort of an articulation, it's got to be designed just like a lifting device in terms of its load capacity, because we are sometimes dealing with millions of pounds of separation force. Yes. The larger you go, even small diameters, something like 5, 6, 7 bar on a 36 inch area is huge loads. Yeah. This particular tool, 16 inch, I don't know, I can't recall earlier in the conversation, what's the client's desired test pressure on this one?
It was 29 bar, which was why we were testing it. Yeah, it was 29 bar, yeah.
Okay. Cool. Now let's just dig into what are customers normally asking when they're looking at this tool, or when they're coming to you with all kinds of other challenges. What are the normal, frequently asked questions that we can kind of walk through one at a time and try to pre-answer those questions for people who are listening to this when they're thinking about, they've got they either have high pressure tests to do, they need a tire tool for doing a range of medium pressure tests, they've got flexible elbows and bends to go around. What are you normally hearing from clients when they're coming to you and they're asking questions? So I want to just spend some time talking about those and see how many, we'll try to anticipate what questions people would be thinking when they hear us talking now. What are the normal things you're hearing?
The first thing we hear actually is, I think they just assume we can do anything. So the first question is basically, here's our problem, can you do it? And they give us minimum information and expect us to be able to solve the problem.
Right.
So we have a bit of digging, we extract as much information out of them as we can. And then immediately it leaves the technical side behind, and immediately it's saying, well, how can we have this?
Right.
And I think that they don't seem to understand, if it's a product that's on the shelf and it's an everyday product, then yes, it's not a problem. But if they're coming to us with what is a problem and it needs a solution, it's very difficult to give a time frame. We try to give a time frame, and we try to say 6 to 8 weeks. But as we found with this tool, once you get into the real testing, of the concept, it then has its own challenges and its own problems, and that time frame, it just gets longer and longer.
Yeah, a lot of the time it's, what I found is the client who's reaching out for that one problem test that, they may or may not even know that it's non-standard. And they're often, a project planner who's trying to find a solution so they can source the right equipment to solve it. Sometimes it's the piping engineer, but a lot of the time it's either the piping engineer or the people who are the work planners, and they don't understand the data that we need or the lead times. And a great project that we've done together more recently for a client was developing test tools for hub connections, specifically some Greylock flange testers, and we actually built. The customer has a lot of these connections, and we actually have a lot of clients who have hub connection flanges because they've moved away from RTJ ring joints in high pressure connections, and they use a lot of hub connections. Greylock is a big one. Another type of hub connection that some of our clients use is another manufacturer, slightly different hub design called Secure Max. No one else is doing that kind of hydro testing with those kinds of plugs, so they're always faced with doing system hydro tests or golden welds or non-destructive testing, and we were approached saying, hey, can you come up with a way to use plug tests on Greylocks? And we said, well, I knew instantly we could, but and they immediately went to, when can I have it? Can you have it here next week? I'm like, well, I don't have it on the shelf. We know how to build that type of a tool, but here's the process. Number one, we need all your data, size, material, pipe schedule, some dimensions around where the weld is going to be to make sure we design, if it isn't, depending on how close we are to obstructions, and obviously the test pressure. And then we have to do the design, and there's a lead time on materials, much like your high tension cables. Building that first Greylock tool for that client, and we built it just to demonstrate to them that it could be done. It was, I think, 4 or 6 weeks to be able to get the hub from Greylock so that we could build the tool. So there's often a lot of lead time, but those things can be done. But understanding lead time from can you do it? Well, I think, between you guys and us, our answer is almost always yes. We can, whether it's challenge accepted or we find a way. Both of us have a similar motto that, I'm certain we can. Here's the date, here's the information we need, and you got to give us at least a few days or a week to evaluate the sourcing of materials, because they don't, many clients don't. When we're developing a new tool, a lot of clients don't understand that we need the data, then we need to do the design, then we need to source the materials, then we need to build and assemble the tool, and we want to make sure we do a factory assessment test in a test rig to prove that the tool is going to do what the client needs before we put it in their hands. So I think on a really fast schedule, that might be 4 weeks, and realistically that's 8 weeks or 12 weeks, depending on if we have tough lead times on things like flange materials or, as you mentioned, tension cables. What else are we talking about? What other kinds of questions other than can you do it and how long? I think it's important for customers to understand the process of what it takes to design and test and make ready a custom tool, so they have good expectations about delivery. We've got some projects going on right now with those Greylock connections. But now the client, we worked with them they came to us with 3 or 4 different jobs and wanted the tool in their hands in 2 weeks. And, we finally had to go ahead and build a demo tool to show them that it could be done and gather all the stakeholders and explain, like, this is a 6 or 8 week process, maybe even 12 weeks if we've got to wait on Greylock to provide the hubs. So if you want to do 20 of these on your next project, we really need to be starting to talk about them and getting commitments in December or January if you want to do these kinds of hydro tests on a maintenance turnaround come May or June, so that they can be ready for you. I think that's a really important thing for clients to understand. Certainly, you guys have been great to be able to do bespoke work in 2 and 3 weeks for me sometimes, but those are the extreme situations, I think, not the norm.
Yeah, no, another thing I find along with everything you've said has been the problem is when it's a new product, a new concept, I always find the client seems to want detailed engineering drawing. Well, when it's something we've not done before, we're not going to spend a week, 10 days doing a detailed engineering drawing and them to then say, actually, we don't want it now. That's a lot of time and expense. And we see this a lot. So we're happy to do general arrangement drawings, and we're happy to do budget drawings. But we are constantly getting people asking for the detail, and you have to explain to them, obviously in a nice way, look, there's a balance here between what we can do up front and what we can do once we've received an order, because it's all time and money.
Yeah, I mean, a lot of the time, with those two kinds of clients in terms of their role, whether it's the planners or it's the engineers like the details, which means, their way of making decisions is show me as much detail up front so that I can make a decision. And when it's an R&D project, the fact is that, as we're developing a new tool, there might be a few different versions. So giving you a detailed design of something that we haven't prototyped and tested and maybe come up and had to make 3 modifications through our experimenting in the shop, it's not the right way to make the decision. What I find with planners and sort of the field execution clients is they want to see it, touch it, and feel it. They actually want a demonstration. Show me this tool. Well, the tool doesn't exist. And then it's a bit of a chicken and an egg thing, with this one client with the Greylock connectors, and similarly with what we did with building reverse tension testers to help another client. They wanted to see it and feel it, and so they weren't able to make a decision until we did that. So what we did together is we just committed to build some of these tools ourselves, specifically on the thinking that if we build it, they will come, and the Field of Dreams with Kevin Costner thing, and and in each case, it's speculating that this, we've got a client that has a lot of need for doing hydro testing that is both radially and axially. That's why we built these flange tension testers, and now we own a fleet of about 80 of them, specifically for one client that has that spec. And now the Greylock ones, similar. We were talking with that client for probably 2 years, saying that yes, this can be done, but each time they would call, hey, I've got a job in 2 weeks. Do you have a Greylock tester? No, we have the ability to build them, but we need a job. And it was kind of that chicken and an egg conversation for quite a long time. And then my sales and my operations team came to me and said, look, we've got to speculate on this a little bit. And so we did. And we worked with you guys, and we built, I think it was a 6-inch Greylock flange tester. And we built a test rig and went to their site and had 30 of their people in the room and demoed that, yes, Greylock's hub connectors can be plug tested. And the minute we had that demo, all of a sudden they had like 30 flanges that they needed to do, in the future. It's quite interesting, whether it's the detailed engineering that you need to provide or if it's the demo. Those two paths seem to be the way to move forward with building new technology. And I think it was kind of similar when we built the elbow test plugs a number of years ago. Everyone said they wanted it. No one wanted to buy one until I bought a fleet of them. What are they asking about costs? Like, how does that conversation go?
Again, it's a new product. It's a difficult one. As we all know, every customer wants everything for nothing. So when it's a new product, it's obviously not just the cost of the materials and the engineering, but it's the test rigs. Especially, you mentioned Greylocks. We ourselves are starting to see this a bit more common.
Yeah.
Most of our in-house test rigs we have do not have Greylocks on them.
Sure, they wouldn't, and it's not very cost effective unless you have a need for them, because I'm sure clients know this when they're installing them on actual piping systems. But hub connection flanges are not cheap. They're certainly an order of magnitude more expensive than weld neck, raised face flanges, and so building testing rigs just to be able to prove the tool, those are thousands of dollars, those flanges. So it's a process for sure.
Yeah, I mean, we recently had a client who was after a smaller size test unit, but with a Greylock. Price without the Greylock was fine. As soon as we put the Greylock on it, they just changed it completely and decided not to go ahead because, as you said, there's a lot of expense. So it is a fine line for us. And even when it comes to the test rigs, if it's a common size and we feel it's something would be used many, many times, then we can try and reduce that cost and then spread it over multiple jobs. But quite common, these tools aren't used that often. So that cost, maybe most of that cost initially is passed on to the first client. I think the trick is not be the first one, be the second one. You'll get it cheaper.
Yeah. When it's a rare job, the first one pays for all the capital costs because you can't, unless they're buying the tool themselves. If they simply want to use it for one test, it's speculative. I know we've got with the Greylock connections. I think we have a client right now that has, I think it's 6 18-inch tests to do. So they are the first client for that tool. When they give us the order, they say it's in the queue. But they're able to spread the cost of that 18-inch tool over six different tests on the one project. So that certainly makes it a little more affordable to do those jobs. What about the idea of has it been done before? Is it proven? How do you I'm sure you get that question a lot. How do you address that with clients?
Well, obviously, with it being a new tool, the answer has to be it hasn't been used before. But we always assure them that we do lots and lots of in-house testing, and we do. I mean, this flexible tester, it's had numerous amounts of testing in and out of the test rig, different ways of lifting, because we're not prepared to let anything leave our facility unless we're 100% sure that it's going to work and it's going to be safe to use.
Right.
So that's all we can really do is give them a bit of verbal confidence. That also, we could end up testing some things that will be ready in 6 weeks. It doesn't work. It's never been used before. It becomes a major problem. So we try our best to meet their timelines and give them the confidence that even though it's not been done, we can do it. We've had to have guys in over the weekend where we thought this tool was going to work, and at the last minute, in fact, this flexible was a perfect example. It was due to ship out on a Friday. It seemed to be fine, and then all of a sudden, it just started to leak and we had a problem. And the guys were in all weekend doing what they could to get this tool working. So everybody, they lost the time off, they lost the weekend, but we still managed to get the tool out the door in the end. But that's all you can do. You can just try and give them as much confidence as possible and try our best to achieve the end objective.
Yeah, I think what a lot of, at least what I see and how I address that with clients, that's probably different than what they're used to, at least in North America, is factory assessment testing. What I love about engineering in the UK is factory assessment testing for bespoke engineering is common practice. It's just how you do things there. So the idea that yes, it's a new tool, but by the time you get it, we'll have already tested it in a test rig and proven it. I think that builds a lot of confidence that when the client gets the tool, at that point it's been used because it's been proven. Not necessarily in the R&D part hasn't been proven, but a long track record of designing tools with similar types of seals and ideas and components. But the FAT is the confidence builder. What I really love about that in particular, you think about a tool that's one use, high risk in terms of make sure it works, is when we work together to design nozzle testers, the nozzle test plugs. And whenever we've built a lot of nozzle test tools with you guys over the last 3 or 4 years, and the nozzle test tool comes housed in the test rig, so that you can literally it ships with it, and so you can show the client, we built the test rig to match your exact nozzle conditions for your pressure vessel, for your situation. And being able to demonstrate that, to actually literally use the test rig to show them that the nozzle tester is going to work is a major confidence builder for them, because a lot of the time when a client is testing a nozzle on a pressure vessel, it's got to work. Like there isn't, it isn't, by the time that they do the welding and they fit that nozzle, they can't, there's no golden weld on a nozzle. No pressure authority is going to sign off on a golden weld if they can't hydro test it. The alternative to the tool not working is to have to fill the entire pressure vessel and hydro test it. And a lot of the time when they're doing that, it's not water. They're having to use methanol or some other much more expensive solvent to do that hydro test. So and it could throw the entire cost and the schedule of the project in array. So the test rigs and the FAT are the tool things that for me as your client and partner builds a lot of confidence for me. And it's exactly how, when we're building custom tools for our clients, that we give them confidence that by the time the tool gets here, it's tried and true and proven. I think that's a really great standardized practice that you guys have, and I know I get a lot of value and confidence from it. I would rather it be take 3 weeks longer because there were some issues on the FAT than to ship it on schedule and test it on this side of the pond.
Yeah.
Right?
Yeah.
What about what kinds of questions do you get about pipe schedules?
Yeah, well, basically, can you do it to this schedule? No, the schedule generally isn't the problem. It's when you tie it up with the factors. We can make anything to any size, but it depends on exactly what you want it to do and how you want to do it. We can make a big plug to go in a big hole. We can make a small plug to go in a small hole, but what's its purpose and what's it need to do? It's when you extract the other information from them and you end up with a whole picture, what's going on, that then starts to raise eyebrows and raise problems. But also, we can't have a tool for every single schedule available. So we'll try to design them to cover 1 or 2 schedules at a time. But then again, if you've got a tool for design for the very large wall thickness, and they go to the extreme of that schedule to wall thickness, we've got quite a large area we need the seals to extrude. So the problem there then is, okay, we can do one that will go into from a shed standard which we're down to a shed 20 something or vice versa. But we then think, well, that affects the pressures, because then, instead of only making up a gap of a couple of mil from the size of the tool to the pipe wall, it's trying to make up maybe 5, 6, 7 mil. So that has further implications on the tools. Yeah. Maybe in time, if there's enough demand and requests for these tools at some point, we may have one every single schedule, or maybe just to cover 1 or 2 schedules. But at the moment, it's trying to cover the range of them as best we can.
And right now, you're talking specifically about the newer flexible tool in terms of what schedules you've got, because I know you've done a lot of work with a lot of your other tools and have a broader range of schedules in some of the more standardized tools that you've got in your fleet now, right?
Yeah, because there's been a large demand for them, then there's a justifiable case to make, a large fleet of these, and we don't just have one to cover each schedule. We might actually have 10 to cover each schedule. We've got quite a large fleet. And it would be the same with this. As demand picks up, if demand does pick up, then, it's worth investing to have more tools available. Because also we can't have customers asking us for the product and every single time saying, well, we need 6 to 8 weeks to develop this and to test it. We want to be able to say, yes, we've got one on the shelf, a bit of in-house tests, and we can get it out in a day or two. Right. And that's where we'd like to be.
What are customers asking about test pressures? Like, what kinds of things are you getting there?
Yeah, so that leads on from the previous question is, depending on the scheduled design of the tool, the test pressure has a big implication on the seals, which is all very well done, so they can extrude and we won't achieve the seal. But also, with this particular tool, as we spoke about earlier, then high pressures have major implications with the joints and the integrity of the joint, the flexible joint, and can it hold? So, again, it's something, since we've experienced the problems with this, it does get looked at. But we can't spend too much time suddenly thinking, right, how is this going to affect us on a 32-inch tool? Somebody rings us up tomorrow and requests us to do a 30-inch tool, then we'll look at it in detail. But this first application of this tool has made us more aware of something which we didn't really think was going to be a major problem. And I think that's just because all our tools we have on the shelf, the ones that go up to high pressures, are all solid-bodied tools. So we didn't appreciate the issue we were going to suddenly see, which we have. So
that force that's created doesn't have a separation force because it's both sides of the seals are tied together, whether it's a flange tester or an internal weld tester or a tire tool. They all have a fixed body that it's pushing against itself, not against a flexible articulation or chain or cable.
Yeah, and I think with any type of tools we do, though, pressure is always a challenge because we like to be able to achieve what the customer wants, but it has to be done extremely safely. And it's always going to be a challenge. We don't want anyone getting hurt, and we don't want tools exploding inside any pipework, which then has its own problems as well. So pressures are always asked about, always inquired about, and they're always taken very seriously.
Mm-hmm. I think we've got tools from you that we've used up to in the range of 8,000 PSI, I think is the highest end that we've used. We've got a lot of your standard tools come, the internal weld testers, when it's schedule specific, they tend to be, I think, out of the box around 3350 PSI. I see Gavin quickly doing math on bars. Yeah. I don't know, who was it said, Winston Churchill said, Britain and the Americas are two nations separated by a common language, right?
Yes.
I know that's true in my household because my wife being from Aberdeen and me being from Canada, and specifically originally from Newfoundland, Canada, we both speak only one language, and it's supposed to be English. And I don't think anyone in the world would agree that either of us speak English, other than the two islands that we both come from. And we've got this beautiful daughter who is a hybrid between a Canadian, a Newfie, and a Scot, and so she's got a really quirky accent. So, yeah, the bar to PSI is just one of 1,000 different terminologies that we speak differently about. What about availability? Obviously, if it's a custom tool and they're asking how long, we kind of had that conversation. But availability for standard tools, you have a fleet of tools in your facilities that you're offering for hire. You say hire, I say rent. You've got a hire fleet in Newton Aycliffe, right?
Yeah, we've got quite a large hire fleet, but the availability is purely down to demand of customers. It depends when shutdowns are going on, or TARs, I don't know what you guys call them over there. But when the shutdowns, turnarounds are on, they seem to happen, due to our climate, they seem to happen around the same time in the summer months.
At the same time, every client has a turnaround or shutdown at the same time, and they all want tools at the same time.
Exactly, and that's what happens. Everything goes out at the same time. So even though we do have a large fleet, they are constantly going out. It's an extremely busy time for the guys in the workshop because nothing ever leaves here until it's tested. It doesn't matter if it goes out, shipped, not used, and comes back in the following day. It will still be tested again before it leaves here.
You're testing the plugs to confirm their integrity and capability before they go out on each hire, correct?
Yeah, every single time, tested it, because we don't know what's happened to them, and obviously it's our responsibility to make sure not that just people are safe, but make sure the tool does what it's intended to do. The knock-on effect of us sending out a tool to a customer doesn't work, and that turnaround, that could be critical to the planning of a whole shutdown that's going on.
Absolutely.
Yeah. So that keeps us extremely busy. We try our best to meet the demands. Some customers are very good when they take our tools. They'll tell us how long they're going to use them for. So if somebody says, I need a 10-inch weld tester, we can generally have an idea if one is due to come back in, and we can try and chase it up to meet their demands.
Right.
But sometimes it's just impossible. It's just too much there. The turnaround of tools from here is just astonishing sometimes, how much is going in and out constantly.
Right.
It's just crazy.
Now, you're servicing all of the UK and the North Sea out of Newton Aycliffe. I know you have offices up in Aberdeen. Do you have any hire fleet up there, or is it mainly a sales office? Like, how do you handle that?
Everything is kept here. There's hire fleet. It's all kept here in the UK. And right. Actually, we service global. We get people all over the world asking even for rental. It depends on what their application is. Global, it's more purchase or manufacturing purchase. But sometimes I have short time frames. So, the Middle East, we get quite a few requests for rental to send them over there. And we do have we have a small office in the Middle East. We have an office there also in Singapore. But they are mainly sales offices. So all the hire fleet is kept here.
Right. Okay. Well, and of course, if any of your customers in North America want hire fleet, I've got lots of them.
Exactly.
So, I probably own more of your tools than you do, I bet.
Well, we haven't. There's the client who actually asked for this flexible one. I think they could be the same. They think own an awful lot of them as well.
Yeah. All right, let's kind of shift gears and think about. We talked about the technology and your company, and we talked about the frequently asked questions that we both get from customers. But what should customers really be thinking about or asking and aren't? Like they're not, they're not thinking or asking certain questions, but they should be. What do you think? What do you think they should be thinking about?
Well, a lot of times they don't even they don't give us the full information of what they're doing. We're doing a 10-bar test on a 12-inch 20-bit pipework. Can you do a tool for it? And I think they disconnect us from what they are. I think that maybe they see us as a manufacturing facility, which, yes, it is predominantly. but we're still an oil and gas company, and they're oil and gas. Myself, 18 years in the field. I've had 15 odd years in the field. So we've been stood where they are, and it's that lack of information and communication. And I think maybe just because they don't realise, we are the same as them, we've done the same thing as them. So it can get difficult trying to extract the information. I find we can also get a little, maybe a few days, we're not talking a long period of time, but a few days in putting together quotes and communicating with the customer. And then something just suddenly gets mentioned and you're like, oh, no, that was extremely important. Maybe you should have told us that earlier. So I think there's very much a disconnect there between us and them. But, they've never met us. We're just somebody in the end of the phone, so I can understand that's how the mentality is. So I'm trying to create up a relationship with the people I speak to, so they have an understanding. What I have found is the better your relationship, actually the less information you get, because they seem to think you can read the mind. Yes.
Yeah. I think the key, particularly whether you're, in our business, we could be doing the testing for them, or we could be hiring the equipment to them. I think the key to reading their mind is having a checklist of a lot of questions to ask for information that they're not going to share unless you ask. There's a dozen with test plugs. There's maybe a dozen questions that you need to try to extract that information out of the client. What are you doing? What are the obstructions? What is the test pressure? Where is the weld relative to the opening? What elevation is it at? Is it vertical? Is it horizontal? A lot of the time, client is thinking, hey, I need a 10-inch schedule 40 plug. Can you ship it? And then you ship it, and they call back and say, well, it didn't fit. Or it didn't hold the right pressure. Well, it wasn't the right schedule. And it's almost always just a misalignment in terms of getting the right information to make sure that you get them the right tool, or you send the right crew with the right equipment.
Another one actually is eventually they'll tell us whether it's vertical or horizontal. So they do always forget to tell us that.
Yeah.
So then you get told it's a vertical.
I always like the inverted vertical ones where they're installing the plug overhead.
Well, this is what they forget to tell us. So they'll tell us it's vertical, but they forget to tell us it's overhead vertical. Yeah. And then all of a sudden there's a problem because the lifting eyes aren't correct in the wrong place.
Yeah, their lifting eyes are wrong, and the tool wants to flip.
Yes.
And you don't have anything. Oh, we can't hold this thing. Well, when you said it was vertical, we set it up to have gravity on our side, not gravity against us.
Yes.
Yeah. I've seen that many, many times. That vertical or horizontal and inverted, the up or down verticals is equally important.
Yeah.
What else do you think clients should be asking us and thinking about when they're looking to either build or hire plugs?
Maybe they should start asking us for solutions. What we have found is a lot of clients will just come and ask us for an existing product which we have. And then again, when you get speaking to them and extract the information, you suddenly think, hold on a minute, we can do this, we can do this, we can try this. So we have quite a lot of variations on some of our tools. There may only be small variations that we have to do, but it's just things which make life easier for the client. Mm-hmm. Instead of just, I want a 10-inch tester, okay, then fine. And then you dig deep, and then they tell you the pressure, and you dig a bit more, and all of a sudden there's just something you didn't know. And go, hold on a minute, well, we can do this, we can do this, we can try this. Also, I'll quite often get a customer asking me for a product, and when I dig the information out, it's actually completely the wrong product. We can offer them an existing product on the shelf, which is a far better solution, far easier and far quicker to use. So yes, I think rather than telling us what they want, they should be more telling us what they're doing, right, and what we could use to solve that problem. Yes. Again, though,
you're bang on the mark there. They should be leaning on us to tell them the best solution, as opposed to trying to decide, hey, I want this tool. I mean, there are some clients who know our equipment really well, know your equipment really well, and know, hey, I want, a standard tire tool. But the best way is to really uncover what is their challenge, what is their particular task, and let us help diagnose what's the best solution. I think that's key.
Yeah, definitely. And when that has happened, you end up with very happy clients because it's just made the whole job a lot easier, a lot sweeter, go a lot quicker.
What about seal surface and pipe wall?
Again, I think customers seem to think that anything's going to go on anywhere and it's going to seal anything at any point.
Right.
So, we need to, be sure exactly what's going on. A problem we don't see too often, but we do, it's where it's the seam weld. If it's gone within a pipe which has got a seam weld on it, they won't tell us the seam weld, or if it's penetrating a bit too far, they don't tell us. So they put the tool in, we've given them what they provided, they've told us everything they can, and then it's come back, well, your tool's not sealing, your tool's not doing this. And again, when you start to dig deeper, you then realise, actually, you're going against a seal. It's something which could be easily solved by maybe just changing the shore hardness of the seal on the tool. It may just be too hard, so it doesn't go over it. Yeah. So it's something we just need to ensure when we get the information, and from that we put the right type seal in, the right type of tool in. We have tools which will have more than one seal in them. So if there's a problem, if it's extremely pitted, extremely dirty, or we know there's a seam weld, we can put one with dual seal in, just to help them achieve the aim. Shipping a tool out, shipping it down the south of the UK, which will take a day, trying to use it fails, there's a day, they send it back because it hasn't worked, we send another one out. It's 4 days, 5 days they've lost just by not giving us, this is the condition the pipe works in and this is what's going on.
Yeah, I think that's key, isn't it? Is really having good conversations with them around the conditions of the piping, seams or protruding roots from the welds, a lot of pitting, crevice corrosion is a big issue that I've seen, particularly on the bottom of the pipe. If they've got crevice corrosion and they've actually got a channel in the bottom of the pipe that they don't tell you about, that, those are, and I've, in terms of being able to hydro test those, we've been very creative in being able to overcome those things if you know about them, whether it's finding ways to fill that crevice to be able to help the seal accomplish the seal, or changing it from, a lot of the time when I get a lot of pitting, we may switch from using a schedule-specific narrow internal weld test tool to just a tire tool, and that gets the job done. But it's really key to understand piping conditions.
Yeah. Laminations we've found with a problem as well. It's just corroded on the inside. They've not cleaned it. The tool goes in, it seals wonderfully well. But obviously that pressure creeps through the split lamination and the corrosion. And it doesn't matter what you do, if you're not going to clean that surface, that tool isn't going to work, and that is another problem. But as long as, once the communication starts and we can advise them, generally they do achieve the end result. It's just taking a bit longer than required.
Right. What about weight? Weight issues to be considered?
Yeah, I would say on this tool in particular, on any tools, weights is the problem, and the handling and the manipulating of it. But on this tool in particular, to due to the flexible joint, this one was difficult to handle and move around. Something we are looking at and addressing. How can we make it better to handle? Do we strip it in future, maybe in some sort of handing frame which they can mate up to the pipe walls so they can push it in? We need to look at it. But all of these tools are there, as we just discussed, they're using different orientational planes, vertical up or vertical down. And the flanges are very, very heavy. These things will not hang level.
Right. Yeah. Are you on the backing plates on the seals, are you using steel or are you using aluminum?
Most of the tools I've seen, it's nearly all steel. It's all carbon steel. I can't remember the grade of it actually, but it's all hardened carbon steel on most of the equipment because we need the strength that goes with it as well. And also it's treated, we call it blackening, and it's treated then to prevent any corrosion that goes on with it. So, I mean, if we use aluminium, I think to get the strengths we require, we'll be getting bigger and chunkier, so we'd still be getting heavy, but I don't know how it would hand up with. The guys on site aren't gentle with this equipment. It gets thrown about all over the place. And then, aluminium isn't the strongest product either. So, yeah, we could build it with aluminium to make it lighter and easier to manipulate. But I think the cost effectiveness and just keeping the integrity of the tool, I don't think it would work.
We've had you build a lot of our tools with X70 aluminum that we were able to find. And it was a cost issue. The material cost goes up. But, for us in particular, it was actually cost neutral because the weight that we saved with, the increase in cost in the material, we saved in the shipping cost because of the weight reduction coming across the pond. Yeah. It was actually cost neutral. So, it was costing us effectively the same delivered at our doorstep, building them out of aluminum because, we're air freighting all that equipment a lot of the time. We don't have time to put it on a ocean liner and wait, 8 weeks to get it, where you guys are building us a fleet of tools or 2 tools and it's going in a crate and it's going to Heathrow and it's flying across the Atlantic at, $2 or $3 a pound shipping weight. So, that we found that to be a valuable thing for some of our applications, not all.
Yeah, well, most of our, I think you must be referring to the twin tire tools. So most of the twin tire tools, they are built of aluminium, but that's because they're not seeing high pressures. And
we did it. We do it with the backing plates on the IWTs, but not the body.
Okay.
Yeah. The backing plates for the seals on the IWTs, we've been able to. So we kind of got a hybrid on our IWT tools where we've got a steel body, and then the seal backing plates are aluminum.
Okay.
The activation nut is still steel, but the plates in between are aluminum.
Yeah.
That takes, I think it's reducing the weight of 30 or 40% of the tool. What about tool length and the length of the joint?
They're specific to application. So if it was for a purchase tool, then yes, it's very, very specific to application. For our rental fleets, we have a range of bodies which we can change. So, they are changed specifically to suit what the client wants. And again, that's just to make it easier for handling, easier for shipping, easier for packing. But it is very particular. We get some strange requests. We had one, someone asking us about a weld which was 12 meters down, and I was like, 12 meters? That's a pipe spill. Yes, we wouldn't be making and that was for the flange weld tester. I wouldn't be making a flange weld tester 12 meters long. Again, as I said earlier, when you get speaking to them, so well, hold on a minute, if we can do an internal weld tester, we can do that. But then it has its own issues with the length of it, because even if it's 12 meters, you need to be able to push this thing in 12 meters.
Yeah, you need a push bar. You need to fit the tool with wheels. You need an umbilical. You've done them with us. But there's a little more planning in doing an inline weld like that. That's 10, 12 meters down the line, because there's just a lot more kit involved and a lot more planning. And obviously, it's not just about pushing the tool either. You've got to be able to measure where the tool is so that you actually get the annulus of the test area over the weld. So there's I've had a few times when customers say, "Hey, can we just push that into place?" Well, yes, but there's a few other things. There's a little more planning involved. I mean, every time I've got to look at doing an inline weld like that, it becomes a custom or bespoke job that takes a little more planning, and there's more materials. And sometimes customers will go, well, I just want to rent the tool. Well, I don't want to rent you a tool and you try to self-perform a test that's 12 meters down the line, unless we also work with you to write the procedures so that it's successful. Those are always a bespoke application.
Yeah.
What about, we talked a little bit about orientation. What kinds of limitations? And this is really, that comes back to vertical, horizontal, inverted, up, down. I mean, there's so many different ways that, the one thing that I do know is if piping engineers can design a strange place to put a weld, they will. And we've got to figure out how to isolate and test all those. What are the limitations that you've seen or that customers need to think about relative to plug use orientation? And what do you do about it?
Well, our greatest issue on this flexible tool, without a doubt, is if somebody wants it done vertically in the upward plane. So we're seeing enough problems trying to use this tool in a horizontal position and trying to get it go into position with it being a flexible joint.
Right.
I wouldn't even like to think how are you going to get a tool with a flexible joint inserted in a vertical upward plane. How are you going to hold it in position? How are you going to get it to go where you want it to go? That we're trying to come back with.
Yeah, because you can't push the plug segment up. It's just going to sit there and work gravity working against the flexible portion of the tool. It's not going to fit into the right location in a vertical situation, is it?
Yeah, exactly. So I forgot to mention this earlier. So part of the research and development for this flexible tool, when the chain was wrapped in polyurethane, they tried to do it in quite thick polyurethane to hold the tool in position. But it then lost its flexibility. It became very inflexible. So yeah, there's a fine balance between can you make it flexible enough so it'll go where you want it to go, but also can you make it rigid enough that you can stand it vertically and be able to push it upwards. So there's a very fine balance. So that is without a doubt, and I think that is in all the orientations, that is our main limitation, is what is the fine balance. And also depends on the length of the joint. If the length's going to be quite short, then yeah, it's easier. But if the weld's a bit further than what's normal, then that flexible joint is just going to become...
Yeah, I guess the weld really depends on, when it comes to a flexible tool, on whether it's a standard elbow joint or if it's a 3 or 5 or 7D bend, and where the weld is on that bend and what you're trying to accomplish is going to have a lot of factors involved in which version of that tool you're going to use, right?
Yeah, exactly. Yeah. I mean, people like to use the flexible twin tires, but as I said, the problem is the pressure limitation.
Yeah, that's right.
Yeah.
I mean, the flexible twin tire tool is the one that our nuclear power plant client used, but the test pressures were very low. So and we did FATs on it, and then we demonstrated it again in our shop, and it worked marvelous, but it was a lower pressure articulated test. So what are you rating the chains for? So you've been able to measure the loads, the forces on the tool, and so how are you addressing sort of safety factor and the ratings on the chains or the cables you're using on the flexible tools?
So what we had to do in this one, as I said, initially when they did the calculations, because the chain was stretching and elongating, we didn't expect to see it. And so then we looked at cable. We know we can get this high tension cable. It wasn't available. So we actually had to go to a lifting company because they're the specialists and they know what they do. So we explained the forces we expect to see, how much weight this chain was going to be able to see and what we had to do. And we let them advise us what the chain was going to be. But say this chain was, I can't think what the weight of it was. How heavy it was? It was a heavy chunk of chain. It almost, even though the tool was a flexible tool, just due to the weight of this chain, we almost lost the fact of this being, a flexible tool to be used on site because then it had its own implications. It was definitely on the limits.
Was it half an inch?
I think it was thicker than that. Yeah, it was something like an inch thick, I think.
An inch thick, and there were only three links.
Yeah. 3 links in it, so there must have been 300 millimeters long per link or something. It just became
It's like anchor chain.
It was almost like an anchor chain. Yes.
Anchor chain, yeah.
So it was at the point where it could be easily enough manipulated for its purpose for what we were trying to achieve without causing too many problems. Any bigger, any heavier, it would have been a major problem. But as I said, we were time limited on this one because the client required it and we come across issues we just didn't expect to see. So the way of addressing that in future is we will use high tension cable, but we need to start doing testing on that and how to stiffen that up again to make it useful, because it's no good having a cable which is going to take 30 ton, 50 ton, 100 ton, because as soon as you pick the tool up, everything just starts flopping and hanging down all over the place. We need to be able to manipulate it. So that's what our next stage of testing will be.
Yeah, that'll be interesting, experimenting with how you encase that in different hardnesses of polyurethane and figuring out the balance between flexibility and load retention and tool usability, right?
Exactly. Yeah. And we also found was that the chain we used initially, just the orientation, the links went onto the joints. They burst the joint open. So I don't know what the word would be, but the joint actually burst open like that because the chain was pulling off at an angle. So when the tool was finally sent, we didn't have the time to change how we were going to do the joint. So that it was put such an orientation, so any forces where the chain was going to bend as such, they weren't going on to the side. So what we've decided in the future is we'll use some type of universal joint with some sort of ball fitting, so it can move any direction we want. So again, it was just another thing we didn't expect to see, but you can test all day long, and that's the whole point of testing, is to come up with
that's the value of the R&D and the shop testing is working out those new tool bugs before they get into the field, as opposed to build and ship, right?
Yeah.
I mean, I as I said, I place a tremendous amount of value on the way you guys deal with test rigs and proving the tool in the shop, so that customers have confidence when it gets to the field application. It might take 3 weeks worth of shop testing and FAT, and it might only be an hour in the field, but there's a lot of situations where that investment for clients saves them hundreds of thousands or millions of pounds or dollars, right?
Yeah, exactly.
What about engineering packages? Are customers often asking for calculations and an engineering design calcs with your tools, and how do you address that?
Yeah, so as we go through the design processes, each revision of the drawing will go to the client. So we would never just, okay, let's take on this issue, let's design it and throw something out at the end. Every single stage drawings are sent to client, then sent for client approval. With any calculations that would go with it, they will look at them, obviously comment, and with that, any little things they don't like, because they may have an idea they think is perfect until they see it in a detailed drawing, see some calculations, and then decide to change things. So a lot of the design drawings will go through various stages of revision until everybody is 100% happy with what the end product's going to be. And that is something that we would do as standard. So it's not something they have to ask for, because we want to make sure the customers know exactly what they're requesting.
Okay. What about diameters? You mentioned this tool is a 16-inch, and you're still sort of trying to figure out, how small and how large you go. Do you have a sense on where you're going to go with the flexible tool?
With the way it is at the moment, I couldn't really envisage it going much above maybe 20 or 24 inch. Again, this is due to the weight and the way it's manipulated. But this is because we haven't looked in great detail yet at how we can ship it, how we can load it, and how we can manipulate it in the field.
Right.
When we do get the opportunity to do that, I'm sure we can come up with some sort of handling frame, some way of manipulating it. And if we can come up with a good solution which works in all planes, vertical and horizontal, then I would say that really there would be no limitation. Limitation would then be weight, which is the same with any type of tool. But at the moment, it's just how we can handle it with the size it is.
And in terms of the your other standard tools or other bespoke custom tools, whether it's the twin tire tool or the internal weld testers, what's the smallest that you've gone? What's the largest that you've gone?
The smallest we have is 1/2 inch. So we have 1/2 inch flange weld testers. I think the smallest internal weld tester, I can't think of whether it's a 3/4 or a 1 inch. It's very small.
I think I own some 3/4 inch double extra strong internal weld testers that you built me. And you know, so that means the seal size or the hole size is like 0.4, like 400 thousandths of an inch or something, or 375, something like that. It's very, very tiny. And because it's double extra strong, it's also capable of testing like 3,000 or 4,000 PSI. It's a very small, it's a very small, impressive tool. Works really well.
And they are part of the standard fleet as well. You know, these, they're sitting on the shelf now.
I don't have one. I think I have 7 or 8 of them on the shelf because it comes up quite often. I think you built me a 1/2 inch tool, maybe schedule 160. That was slightly smaller. But I mean, when you get down that tiny, you know, the difference between a 1/2 inch 160 and a 3/4 inch double extra strong is literally thousandths of an inch. Yes. But those thousandths of an inch matter. They matter a lot to be able to get the test pressures off. It's quite a feat of engineering to have such a small package to be able to be so capable. What I love about them is, they work just as well and as fast as some of the more manageable sizes. I mean, these are tiny tools that pack a punch. What about on the large size? Where do you have? Where have you gone there?
So the larger size isn't too common. So if I'm thinking about rental fleets, so our largest item in the rental fleet is a 36-inch flange weld tester, right. And it doesn't go out too often. For internal weld testers, for the fleet, I think the largest is a 16, and again they don't go out very often. Mm-hmm. It's always the common 10, 12 inches, which we have lots of. Right. As far as the twin tires, I think our most common size, and I think our largest then is a 16 or 18 inch. And that's just due to customer demand.
I mean, that's, if you think about what customers' demands are, it's, up to 16 inches where most of their pipe works are going to be. And they've got just fewer needs for 20s, 24s, 30s, 36s. So, I mean, we have them. I think the largest tool you've built for me was a 42-inch twin tire. I think I have 2 of them on the shelf, and I've got 5 or 6 36-inch tools. But the strange thing is I think the last time I used them was 5 years ago.
Yeah. Well, if I need them, I'll ask you to rent them.
Yeah, absolutely. They're sitting here waiting, and they're made of aluminum. Do you know how many years it took me to be able to say that word?
Aluminium, I can imagine, yes.
I probably was in your offices and dealing with you guys for probably 2 or 3 years, and I could not say aluminium. I would say aluminum, and then you'd all chuckle, and then I would try to say aluminium, and then I'd trip on my tongue. And now I say aluminium at will, but only if I'm talking to Brits. No one else knows what aluminium is, but whenever I say it, I get a chuckle when I say it in Canada. Yeah, so I mean, it's an impressive fleet. When I look at our fleet, of tools that we've built with you over the years, the custom tools, the standard tools, how we've made certain custom tools into standard fleet. I mean, we built and designed all of the elbow grip plug tools together that we call the longbow. after the British longbow. That was an idea that I drew on the back of a napkin, and then we developed it together. And and then we've got the reverse grip test tools that we designed to support ExxonMobil. And now we've got the Greylock test tools, the flexible tire tools. Now you've got this new flexible higher pressure tool that you're developing. The range of dual tools, both schedule specific and multi-schedule, the IWT tools or the internal well test tools that are, self-energizing and high pressure. I think what a lot of clients need to understand is that the way I think about test plugs, isolation of test plugs is most of the other players in the marketplace are mass producing a single tool that's almost always just a compression O-ring tool, and they try to sell one tool does everything. And so it's the way I think about it is, if you're a tradesman, you wouldn't have just one screwdriver or one wrench, spanner, your word, spanner, in your toolbox. You'd have a whole set of them because you need a whole set of tools to be able to do your job. And what I like about what we do together, what IK has been so great at engineering and testing, is building that whole toolbox of isolation and test tools so that all of the strange configurations and challenging configurations of piping that clients have in the field, you can actually isolate them all, you can hydrotest them all, and you can get the work done. Because I think what clients face so often is they use a standard tool that is the one size fits all that is available in some markets, and they can only accomplish 60 or 70% of their work, and then they end up having to do system hydrotests or golden welds or in-process weld inspection, and a lot of the time they don't even know that that's going to happen until the standard tool doesn't work, and that can be a challenge. And I think the ability to, one, have that whole wide range of capabilities that you guys develop, and then secondly, outside of that, be able to pick up the phone and say, hey, I've got another crazy one here. Can you guys find a solution? And you almost always do. I think it's just clients understanding that that's available. And then number two, knowing that, if it is a strange job, the big process for success is giving us the time to work with them with the right information so that we can design and test and prove the right solution. And that always works. I mean, the success that we've had with doing bespoke nozzle testers for clients has, been a tremendous success for us here in Canada. And I think, as clients get to know you guys around the world, I think they'll be pleasantly surprised with how much safer, how much more productive, and how much more cost effective working with you guys can be. And so I hope our audience gets some value out of this conversation and reaches out. And what we'll do in the show notes as we publish this is we'll make sure that we share websites and phone numbers for both IK UK and obviously for our company Innovators. So depending on what side of the pond we are on, we'll be able to support our customers around the world. Any closing remarks, guys? Any final things you'd like to share?
No, it was interesting. Nice to talk.
Yeah.
No, nothing at all. Yeah.
Awesome. Well, you guys have a great Christmas season, because I may not talk to you before then. I'm going to go and sun myself in Mexico for a couple of weeks, starting around the middle of December until the middle of January. And what people don't realize is we only have 1 month left in this decade. And here is to a brand new decade in the 2020s. Who would have ever thought we would have been talking about the 2020s?
It seems like yesterday when it was the millennium change, didn't it?
I was just thinking the same thing. For me, I remember the anticipation leading up to the millennium and Y2K and all that stuff. And Wyatt probably remembers that too, right, Wyatt?
I was 2 years old at the time.
2 years old.
Yes, I'll admit to that now that I don't have the best memory of it.
You've heard of Y2K, but
I'm aware of it. Yes.
It's kind of like me hearing war stories from my dad, you know.
And there you have it, though that doesn't have to be the end. If you haven't already, please give us a follow wherever you find your podcast, and don't forget to check out both our host Don Cooper and his company, Innovator, as well as our guest by following the links in the description.